about hazardous energy control. Also, you're going to hear this referred to as lockout tagout quite a few times. So when we get into hazardous energy control or lockout tagout, some of the things we're going to talk about in this program are going to be the definitions, types of hazardous energy, our policy, the procedures you're going to use for isolating hazardous energy, and then different types of equipment you're going to use for such a procedure. So what is the control of hazardous energy? So it provides a systematic process to really, control, understand, gain control of hazardous energy. So this could be in multiple different formats, and a little bit here we'll go through different types of hazard energy that you might provide. Okay, but the biggest thing is a systematic process of protecting our members when we're working around different types of energy sources. So with any policy or procedure we're going to have, or any set up standard for operating, this is going to give us a minimum requirements of how to isolate, lock out, and then release any types of stored energy. What we may find, generally may find this on rescue operations that involve elevator rescues. So we might need to control the power or the hydraulics for the elevator. This may also come into play for industrial rescues. So if you're working in some sort of industrial facility, this may also come into play. Even think of the basics of a vehicle accident, where we want to disconnect the battery and isolate the hazardous energies. So with that, there's a few definitions here. There's only 3 of them. So an authorized member, that's somebody who, by virtue of this program or by training in the Alpha Fire Company, has had or demonstrated proper procedures to identify energy sources and then lock out and tag out those sources. An energy isolation device. This is generally some sort of mechanical device used to shut off the energy flow. This could be something as simple as a switch or some sort of a switch lockout. Could also be closing a valve and keeping the valve closed. So truly it's just any type of mechanical device that's going to be placed on the operating equipment or the switch or in line. It's going to limit the flow or transfer of energies. And then exclusive control. So exclusive control will be used for something, let's say we have a large machine or a large pipe, and we have no way of once we close the valve to keep it closed or verify it's going to stay closed. What you can do is put somebody in place. They would stay within sight of that mechanical device, and they have control of it, and they can verify that nobody's going to walk up and either turn the device on or off or open or close the valve. So let's think of exclusive control. We do an elevator rescue. Somebody goes to the penthouse or the elevator control room, turns the switch off, disconnects the power, shuts the valve off to the elevator car, but they don't have some sort of mechanical device to actually lock out that device. If they stay in the room, if they stay within sight of that control, if they can somewhat block somebody else from walking in the room and turning the power on, then that would be what exclusive control is, and they actually stay there and use their body or themselves to limit the machine from being turned on. So with that, we'll move into different types of hazardous energy. So as you can tell, or as you see here, electrical energy. So this could be as low as 30 volts. Could also, or as low as 30 volts, can be enough to kill someone. Amperage would be the current, is another factor that we want to think about. So lethal amperage is 0.07 amps or 70 milliamps. And with that 70 milliamps, saying that's a lethal dose. A taser works at 600 volts and 2 milliamps. So this is why, if you kind of use that taser idea as an example, why a taser generally does not kill somebody. It's only enough to stun them, and that's because it's only at 2 milliamps. If you would use 35 tasers at the same time, then you'd probably have enough electrical energy to kill somebody. The next is mechanical energy. So with that, we have 2 types. Kinetic is any sort of mechanical energy in motion, and potential would be anything that is stored or at rest. So think back to maybe your hose line operations. If the hose line is full, Okay, water and the valve is closed, that is potential energy. And if you open the nozzle and start flowing water, that is kinetic energy because that fluid is in motion. So that's for mechanical. Hydraulic will be energy of fluids under pressure. So on the left side there, it's a water jet. So they're using water at high pressure to cut steel. And the picture on the right is some sort of a press using hydraulic fluid, much like a hydraulic cylinder, to increase the pressure, and that's the pressure use of fluids. From there we move on to pneumatic energy, just compressed gases. It can be any type of compressed gases. Generally what we're going to deal with in industry will be compressed air, and that's what they're showing you on the right side is a large air compressor. The next would be gravitational energy, uncontrolled lowering of a weight in a system that operates mechanical advantage in the system. So gravitational energy, mechanical energy, I think gravitational will be much like gravity. So if a vehicle is sitting at rest on suspension and for some reason the vehicle moves, it's going to move up and down. The gravitational forces is trying to bring it back to Earth. If you knock your soda or water off the desk, gravitational energy is going to be forcing that or moving that material closer to the Earth or using gravity. So it's an idea of what gravitational energy we may deal with in industrial settings. We also have chemical energy hazards. So if you think to yourself what type of chemicals may start fires or be an issue or in a industrial type setting or a rescue type setting. So if we had gas leaking from a car, that would be a form of chemical energy, okay, that has the potential to start fires. We may also have chemical energy if you get it on your skin. It's going to create burns on the skin, or the same chemicals, if they're released from their container, may produce harmful gases and fumes. Some of these gases or some of the chemicals we may find, could be acids or bases, can react with our skin. With our harmful gases, as they are mixed together, such as pine sol and bleach, make chlorine. Chlorine that was supposed to be in storage tanks may spill and then off gas. So these are different types of chemical energy hazards you may find in the rescue world. Thermal energy could be from hot equipment or fluids that will burn you. Could also be from cold fluids that may cause injury, freeze injuries. Also, the quick release of compressed gases can freeze your skin. So the picture here is a plasma cutter used to cut steel. So in this case, this is high energy along with high pressure used to cut the steel, which again is going to be could create a thermal burn. So you'll see this person working beside this piece of equipment is probably wearing some sort of flame retardant material, maybe wearing a flame retardant jacket or a leather jacket. Just something that those sparks are not going to burn through or protect them from the heat. From that we have radiation energy. So this could either be thermal or nuclear reactive. So thermal could be radiation in many forms from thermal properties. Heating elements using infrared. So infrared is a type of electromagnetic wave that can carry heat. We also have nuclear and radioactive. So radiation may be of a nuclear radioactive source. It could be gamma or neutrons. For this, shielding may be the only option for engaging in a lockout type out process. So just need to be cautious when we work around anything that's going to be nuclear radioactive or give out some type of thermal radiation injury. Hopefully, if this is found within a work site or a rescue area, it's going to be marked that we're going to be able to we'll be aware of what's going on around us. But really just watch out for that nuclear sign that we've seen in the hazmat world as an indication of our work and what we're being exposed to. So for us, we have a policy. So it is the policy of the Alpha Fire Company to provide procedures for all members who work on or around equipment where the unexpected energizing startup motion or release of stored energy by the equipment could cause injury. So this process should be applied to all sources of energy which could cause injury during emergency operations, which include electrical, mechanical, chemical, hydraulic, pneumatic, radiation, thermal, or gravitational. So with this, there are two caveats though. The procedures do not apply in minor operations, which are integral to the use of equipment during operation. Members are not required to remove or bypass a guard or safety device, and members are not required to place any part of their body into an area of the machine where work is being performed that is not part of the emergency operations. Okay. So with that, a plug and a cord connected to equipment are not covered in this policy. So we understand that the plug or the cord is the only source of energy for the machine involved in the operation, and the equipment remains unplugged during any operational activity. The plug is under the exclusive control of the member performing the operation, and there is no source or stored potential energy present. So what it's really saying is once the machinery is unplugged, then we reduce the potential for any type of stored energy being present there. This is required as an OSHA 29 CFR 1910-147, the control of hazardous energy. So that's why we're going over this, is because it is an OSHA standard for you to be trained in the control of hazardous energy. So we'll move on to the procedures now. So our shutdown and lockout procedures. Shutdown and lockout procedures shall be requested of equipment owners during the action plan size up of the incident. So what we're saying here is we just want to talk to the people who generally work with this piece of equipment and involve them in the size up and really have them kind of guide us as far as how to shut down a piece of equipment. The shutdown lockout procedures should be reviewed by the appropriate personnel before this operation is undergone. Now, if there's nobody on the scene that can answer these questions, then we're going to need to go with our experience and our training. But if there is somebody on the scene that can answer the questions, that's truly the person we need to be going to. So you think you go into a large industrial facility, they have multiple pieces of machinery working, and we request to shut down one specific piece of equipment, possibly because of an injury or because of fire, because of any other, I guess, its involvement in the operation. We need to understand if we shut down one piece of equipment that may have underlying effects on multiple other systems within the facility, and this is one of the reasons why we need to contact a representative from the facility and truly let them guide us through our operation. Then we're going to start our energy source survey. So this is where we're going to use our paperwork, and I'm going to go over that in a few moments. We're going to work down through the survey, and all the survey is really giving you a check sheet of things to look for, whether it's yes or no, does it apply to what we're working with, does it not apply, but it's really just a guide for working through how to limit or shut off the energy sources used within that facility or within that area of operation. So this is our policy for operating or controlling the hazardous energy. So this is out of the guidebook. So I'm not going to read this verbatim, just to understand that there are a few points on here. Non-fire department lockout tagout equipment shall be deemed acceptable for fire department operations. So it's really saying that what we have carried on the rescue is going to be sufficient for our lockout tagout operations, at least as best we can do. We should, to the degree practicable, potential hazardous stored or residual energy shall be relieved. Remember, that is the degree practicable. So if I have somebody stuck inside of a conveyor belt and I shut the power off, I lock it out, I limit the control from that, and then one of the last parts that we talked about is actually verifying that machine is shut off. There's always the potential that if I restart the machine, yes, it is shut off, or no, it's really not. It may jolt forward or continue to run. And that's where I say the degree practicable is you really read the job and understand and think, what is the potential if I push this button one more time? or if I just let it go as it is and I've done as much as I can to limit the energy sources for that piece of equipment. Prior to the removal of any lockout tagout device, command shall verify all non-essential items or persons have been removed from the operational area, and that it's safe to remove the lockout tagout device. So even if once we put a lockout tagout device on, that device may stay in place until maintenance arrives, or maintenance completes their operation, and then we work with them to remove the devices that we've added to that machine. So this is your hazardous energy source survey form. You'll see as you work down through this, there is both electrical, mechanical, hydraulic, and pneumatic. So they're the four main bullet points we're going to work on. You'll see on the electrical energy side, AC voltage, DC voltage. We're working with a battery, a capacitor, a generator. Description of that energy source. Is there a disconnect? Is it lockable? So another one there would be the hydraulic energy. Yes or no? Is it a pump, a cylinder, hose pressure, fluid column? A description of it, a source of energy. Can it be disconnected? Can it be lockable? So you'll see each one of these has its own bullet point, and really, as I said before, it's just a check sheet to verify, are we doing the right things to limit the energy within this source. You notice I keep using the general term energy because it could be any of the four: electrical, pneumatic, mechanical, hydraulic, or one of the other ones, the brief ones I did talk about before. But these are really the big four. So moving forward for our procedure, so the lockout procedure shall only be utilized by authorized members, so that would be anybody in a company that has been trained to do this. And then we're going to survey the equipment. So prior to performing any operations, the authorized member shall survey the equipment and determine if the job requirements result in exposure to hazardous energy sources. Or really, do we need to shut off the electrical source or the energy source? From there, exposure to hazardous energy requires the implementation of the department's control of hazardous energy procedure. That's what we've already talked about a little bit. And then we're going to lock out procedures are mandatory in several circumstances. So this is when you really need to complete a lockout device, or really kind of get into it and actually do some work. So whenever a machine guard has been removed, whenever safety interlocks have been disabled, when operations are required inside of an energized electrical panel, whenever a person is entrapped, entangled in energized equipment. Okay, remember that may involve our rescue operations. And again, when we say energized equipment, may mean any sort of energy that machine operates with. Okay, so it may be electrical and hydraulic, or maybe electrical, hydraulic, and pneumatic. If a lockout is necessary and the authorized member is unsure of the equipment, you should request the shutdown lockout procedure of the equipment owner. So depending on what type of facility we're working in, they should have some sort of procedure already in place to shut down that piece of machinery even whenever they're doing their maintenance operations. So that should already be in place somehow. From then we're going to make a notification. So if the operations require the application of a lockout device, that the authorized member or yourself shall coordinate with the appropriate person to notify all affected areas. Again, like I talked before, shutting down one piece of equipment may affect other areas of the facility or other lines, other procedures. So we need to make sure that we pass that information on to others. From there, we're going to shut down the piece of equipment. So with this, in orderly shutdown, the equipment shall be complete with every effort made to eliminate the storage of hazardous energies. So bring all necessary energy sources to zero energy, and that is stated by shutting off and isolating energy supply points. So you're going to shut off the power, which could be a switch. You're going to shut off a ball valve. They may be supplying hydraulic energy or pneumatic energy. The authorized member then shall bring all necessary energy sources as determined to zero energy, as I just stated. And this will apply to any electrical, mechanical, pneumatic, hydraulic, or thermal energy sources, which may create a hazardous condition during the completion of the required operation. These energy sources must be either physically disconnected from the machine or an energy isolation device shall be installed and utilized. So then we'll move on to, we're going to talk about disconnecting physically versus using a breaker or a switch. So what is lockout? Okay, so then we're going to move on to lockout. So the authorized member shall attach a lock and a tag to each isolation device so that somebody can't walk up to it and operate that piece of machinery or turn the machine on. So do you see there's an issue with just turning a switch off? So if I walk into a room, turn the switch off because I don't want the power on, and I leave the room, I want the lights to stay off. Is there anything limiting the next person from walking in the room and turning the light switch on? No, because there's no control device for that. Or much the same, if I have a water spigot on a sink. If I turn the sink off because I don't want anybody to turn the water on, I walk out of the room, the next person walks in, there's nothing that's going to limit that person from turning the water on. What we want to do is put on some sort of device or apply some sort of device that's going to isolate it. It's going to shut it down, one. It's going to isolate it, and it's going to lock out. So the next person that comes in can't turn the water on because that device has been locked out. So once we've locked out that device, okay, we've controlled the energy. Now we're going to release any stored energy. So all potential hazardous stored or residual energy shall be relieved, disconnected, restrained, or otherwise rendered safe. This is the question as far as working at the degree practicable. So if I can relieve the pressure, then I'm going to relieve the pressure. If there is a possibility that relieving the pressure may increase the severity of the injury or the entrapment or confinement of the victim, then we're going to forego relieving the stored energy, and we're just going to kind of go with it at where it's at and potentially not add any injury to that victim. Okay, and that's something you're going to need to decide on. So moving from there, we're going to verify that the machine has been locked out. Again, with this goes back to, do you push the button one more time? And that is really going to be a decision by the person that is operating or conducting the lockout tagout operation. I sometimes question pushing the start button one more time or operating a power lever do I really want to add adding more injury to the person. Now, one of the things you could use is an electrical testing device. So you turn the power off, you lock the switch out, and then you check it one more time with some sort of electrical tester to verify that yes, the power has been turned off. So after the verification is complete, the authorized member shall return all controls to the off position. Okay, that would be turning it on to see if it works, and then turning it back off. Again, this may seem a bit confusing to you, and we'll talk about it more when we actually do the hands-on operation. But once you have everything, we have something turned off, locked out, tagged out, and controlled. To really verify that, one, you either have to let it go and accept what you've done, or move the switch or move the valve one more time just to verify that it has been locked out. So different types of equipment we're going to use for these lockout tagout operations. On the top you'll see there are padlocks. So these are off of the rescue. The ones on the left are a blue lock, so you just have a blue mark around the bottom of them. Then the ones on the right are going to be red. So all the red ones should operate with the same key. I believe the ones on the left, the blue, should operate with the same key. And then the one in the middle, the white one, there is only one key for that. Okay. So how we operate with these, if you put a lock or a gang lock or a lock on something, then you take that key, and that key either goes in your pocket or it goes to command. If we're using multiple keys and multiple locks, we're going to lock out, multiple locks. So we're going to use multiple blue and multiple red. Then the keys from the red and the blue go back into the box, the lockout tagout box, and then we use the single white lock to lock all of those keys inside the box, and then we're going to keep a hold of the one white key for the white lock, if that makes any sense to you. So everything goes in one box, and then we just have one key that lock controls all the other keys. So as I said before, the red and the blue locks used alone with or without locking devices. The keys, I said, will be placed in the lockout tagout toolbox and secured with the white lock to maintain a single point of control on all lockout devices. Below that you also see a gang lock. So a gang lock is used for multiple locks on the same device. So let's say for this we have the fire department's working there, so we put a lock on there with a gang lock, we put our lock on it, and then maintenance arrives and maintenance puts their lock on, and then the electrician arrives and they put their lock on it. So now we have 3 locks on the same device. Once the fire department is done with our operations, we remove our lock and we're free to go, but the facility now still has 2 other locks on it. Now the device is controlled by both building maintenance and by the electrician. And that device cannot be reactivated or restarted until all locks are removed, until all 3 people really verify that they're done working with that piece of equipment and can go back into operation. We have breakers and switch locks. So on the upper right hand corner, those are breaker and switch locks. So if you think about it, in theory, if you turn off a breaker in the panel box, there's nothing that's going to limit somebody from walking up and turning that breaker back on. With these devices, we can place them on the device or on the breaker, and then place a lock on that breaker so it cannot be turned on. That's the pictures in the lower right corner. We also have plug covers. So if you have some sort of device that is plugged to the wall or plugged to the energy source with a plug, we can unplug it and then put a lock on the plug so then the plug cannot be reattached to another energy source. So it's one way of taking that piece of equipment out of service. Gate and ball valve locks are used for gate valves in the lower right corner. Okay, just a way of keeping you from turning that gate or ball valve. The quarter turn valve on the lower side is used for a gate valve, or actually, sorry, a ball valve. And that just limits you from turning the lever on that ball valve. Blanking or blinding. So this is an operation whenever for the closure of pipes, line, or ductwork. And with this, let's say you take the valve apart, or you pull one side of the valve away, and you actually put a device in there that's going to limit or it's going to stop the flow of material. So you actually put a device in that's going to block the pipeline. Double block and bleed. So this is an operation where generally it's going to have 3 different valves. So if you look at the lower picture in the right corner, so you have 2 horizontal valves. You'll close both of those horizontal valves at the top and the bottom, and then you have 1 valve in the center, and that's going to remove whatever stored pressure is left between those 2 valves. So with this double block and bleed, with both valves closed and the center one open, for some reason either the top valve or the bottom valve leaks through, that residual pressure is going to be relieved through the open valve in the center. Generally, we're not going to add any type of double block and bleed as far as the fire department. This is something we may use when we arrive on the scene to industrial facility. This would be already in place, and we would operate these valves. Now, generally, for a facility like that, they're going to have some sort of maintenance personnel on the scene, and I would expect them to be able to shut this system down, shut down the valves, open up the center valve, and take care of this operation for us. I want you to be aware of what double block and bleed is, and then what also blanking is. So line breaking would